Amazing.
Vedantu. Learn live online. To attend a free live class, download the app now.
Hello everyone. Good afternoon. Hi Pushpa, Ramita. Good afternoon, good afternoon. Narotan, hi. Narottam. Okay, Nantini. Hi Ramita. So tell me, how are you all? How are you enjoying in this very fine afternoon? Tell me that. Hi Prince. Hi Nishi. Okay, I got so many students in this class today. I'm so happy. Tell me, how are you all? All cool? Fine? Good? How's your preparations going for the exams? For your upcoming board exam, how's it going? Tell me that. We have a lot much to discuss about it. Bittu Kumar. That's a nice name. Agansha. Hi. So, I know that there are so many out there who don't know me. So for them, myself Ameer Basit, Master Teacher of JEE Physics at Vedantu. You can call me Ameer for anything and everything, but only for physics. Okay. So I hope you guys might be knowing why we are here. So we are here as a part of CBSE Sprint to make ourselves prepare for the upcoming board exam. Okay. How? So we'll be doing the previous year question papers. Okay, chapter by chapter, and also we'll be doing a quick revision of the chapter. And I hope you might be knowing what we are going to do today, because we are going to continue the class from where we have stopped in the last session about electrostatics. All good? So how many of you like the chapter electrostatics over here? Tell me, how many of you guys like the chapter electrostatics? No one? How can that happen? Because that is one of the important. You like? Okay, very good. Because it's such a beautiful conceptual chapter. Okay, once you get the concept, it'll be so much interesting for everyone to do the questions and to even to attempt the question. That beautiful the theory is. Okay, me Aditya, very good. Sir, daily hoga na? Yeah, of course. I have already started with. Next class will be on Tuesday. Okay, so today we'll be doing electrostatics, and soon I'll share you the schedule also. Don't worry. So shall we start it? About this percentile and all we'll be discussing at the end. So we'll discuss some of first we'll talk about the chapter electrostatics. Fine. So shall we start? Everyone with me now? All with me now? Shall we start with the session? Yes. Josh? Okay, very good. So before starting with the session, I just want all of you guys to go through this particular quote. What does it say? What does it say? Nothing is impossible. The word itself says, what it says? I am possible. Okay, can you see that? It says I am possible. I just gave you this particular thing because I know that many out of you who's there is feeling low, because you might have thinking that you haven't done enough preparation for the exam. Lot many topics are there, lot much to go again. Okay, just forget about everything what is happening around you. Just you can do the things what is supposed to do. What you're supposed to do? Study, right? Just study that. Don't think about the future. Live in the present with a smiling face. Go to the exam hall with a smiling face. Come out of the exam hall with a smiling face, and just enjoy your life. Okay? So that's what I want you guys to do. Okay? I hope you'll be doing. Then everything will come in your way. I can assure you that. Okay? And everyone will be able to do whatever they're desiring for. Okay? That's how the life is. That's how the life has to be. Yes or no? Yes. Very good. So we have the first question in front of you. What does it say? Define an equipotential surface, then draw equipotential surfaces in the case of a single point charge. So second question. And the third, can electric field exist tangential to an equipotential surface? Give reason. Three questions we have. So first question is equipotential surface. What is this equipotential surface? We'll try to cover the maximum prints. Okay, so what is this equipotential surface? Equipotential surface, from the name itself, it is very clear. The surface which is having equal potential, which means if I'm drawing a surface like this, guys, if I'm drawing a surface like this, 1 minute. Okay, so let me draw a surface like this, and if this particular surface corresponds to an equipotential surface, if I mark 2 points on that surface, the potential should be the same. That kind of surfaces are simply called as equipotential surfaces. So whenever someone asks you the definition, you have to give this. Understood? Very simple, right? Aditya, Anjali, Narot and Kumar, isn't it? Yes or no? Tell me. Isn't it so simple? Yes, no, no responses. That's not good. Guys, you have to be active. If you guys are not active, I will also feel low, right? So I think you want the best out of me. So you have to stay active. So I'll also be active. So we'll go for the next question, right? Okay, what does it say? Equipotential surface in the case of a single point charge. So how will I draw the equipotential surface for a single point charge? As I have told you, in the case of a single point charge, how the electric field lines will be? Electric field lines will be in the radial outward direction, right? So this is a single positive charge. Let this be a positive charge. The electric field lines will be emerging outside, right? So how did it become spherical? So everyone is giving me the answer as spherical. Okay, how we got to know that this equipotential surface is spherical in nature for a point charge? Because we started to mark all the points which are perpendicular to the electric field. Now, why am I marking all the points which are perpendicular to the electric field? Because if I want to move anybody perpendicular to the electric field, should I have to apply any force on the body? Thank you so much, Shibraj. Should I have to apply any force on the body if I want to move the charge perpendicular to the electric field lines? Should I have to? Give me a yes or no. No, I don't have to. I don't have to apply any force, because if I want to move the charge, suppose think that you are having a plus q positive charge. If I want to move this in this direction or in this direction, I have to apply an external force, because if I'm moving this plus q along the direction towards left, I have to apply an external force, because this positive charge will be giving a repulsion. So I have to give an external force. So that external force will make the charge move and will be producing a work. Okay, but in the case of a perpendicular motion, there is no other force where I have to give any external forces. And if I don't want to give any external forces for the body, the work done will also be what? Work done will also be 0, because work is equal to force into displacement, right? If the work done is equal to 0, the potential will be the same in all those points, right? In all those points, the potential will be 0. Yes or no? Sorry, no, it is not 0. The potential will be the same. Yes. So if the potential is the same, if I mark all those points, if I collect all those points, I will be getting what? I'll be getting the equipotential surfaces. So for the positive, as the lines are radially outwards, now this is 2 dimension. If you have 3 dimension, electric field lines will be everywhere outside, right, in a radial fashion. And if I mark all the points perpendicular to the electric field lines, it won't be a circle, it will be a 3-dimensional spherical surface. Understood? Why for a point charge the equipotential surface is spherical in nature? I hope nobody will be having a doubt now, right? Electric field cannot be spherical. Electric field lines represent the direction of the electric field at that point, right? So for a positive, it is radially outwards for a positive charge. For a negative, it is radially inwards, right? Hi Nirmal. So guys, understood the second question? Everyone, Yuvika, Aditya, everyone over there, understood or what? All good? Yes or no? Say yes or no so that I can jump to the next question. Guys? Yes? Very good. So, next question. Who will tell me the answer? Who will tell me the answer? Can electric field exist tangential to an equipotential surface? Very good, Nigda. Okay, all understood. Now the next question is, yes, I am from Kerala, Karthik. So, the question, can electric field exist tangential to an equipotential surface? No. Why? Suppose think that this is the equipotential surface, right? Suppose think that this is the equipotential surface which I have drawn, and if there is an electric field tangential to it, which means along that particular plane, if electric field is there, will this be acting as an equipotential surface? No. Why? Because if I want to move the charge from this particular point to this particular point, as there is an electric field tangential to the surface, I have to do some work. If work is there, obviously it will be producing a potential difference at that point. If potential difference is there, the definition of equipotential surface itself won't be valid. Yes or no? Yes or no? Tell me that. So the entire concept of equipotential surface itself won't be valid. So electric field cannot exist tangential to what? The equipotential surfaces. Yes, all good? Yes, very good. Aditya, Anu, Nishi, okay. I'm so happy that you guys are still active and feeling so energetic at this point of time, 1:15, even without thinking about your lunch which your mom is making, right? How many of you are waiting for your lunch? Or how many of you had it already? Don't worry, once what I told you is, if electric field is there along the equipotential surfaces, we have to do some work because I have to apply some force to make the body move, right? Because electric field is there, and if I keep a plus charge, if I want to move, I have to do some external work by applying an external force. So if I apply some external force, work will be done. If work is done, this point and this point will be having different potentials, right? Because potential itself is defined as what? Potential itself is defined as the work done for bringing a unit charge. Yes, very good. Sir, you're damn good looking. Thank you so much. That means a lot. Okay, I'm so happy. Maybe those words can make my day. So shall we go for the next question, guys? So you keep moving. If you don't study whole study, can't they understand? Okay, let's move to the next question. An electric dipole of length 4 centimeters, okay, when placed with its axis making an angle of 60 degree with a uniform field, experiences a torque of 4√3 Newton per meter. Calculate the potential energy of the dipole if it has charge of plus or minus 8 Newton Coulomb. I hope everyone knows what is a dipole, right? A dipole means two equal and opposite charges. Two equal and opposite charges. 1 minute. So two equal and opposite charges kept at some distance are called as what? Dipole. So we'll be having a negative charge. I'll be having some positive charge kept at some distance. The charges are given. This is plus nanocoulomb. This is minus 8 nanocoulomb is the distance given. So nothing about the distance is there. So this is what? This is the dipole. What has it said? Placed with its axis making an angle of 60 degree with the uniform electric field. So this dipole is making an angle of 60 degree with an external electric field. So if I'm marking this as the electric field, they are making an angle of 60 degree. What we have to find out? What is the question? Calculate the potential energy of the dipole. How many of you know the equation for the potential energy made by the dipole if it is kept in an external electric field E? Okay, we'll go to the answer. First tell me the question which I told. Give me the answer for the question which I asked. What is the equation for potential energy? Where is it? Yes, very good, very good, very good. So the equation for potential energy U is equal to minus of P dot E, right? Which is equal to minus PE cos theta. Now theta is given in the question. How much it is? 60 degree. But you don't know P, but you don't know the electric field also. So you have to find out that. So how will you find this out? How will you find this out? For that, an additional information is given in the question. What is additional information given? The torque experienced by the same dipole and the same orientation is given as 4√3. How will you write the torque formula? Torque is equal to formula P cross E, which is PE sine theta is equal to how much? 4√3. Or you can write 4√3 is equal to PE. Theta is how much? What is theta? Sine 60, which is equal to PE √3 by 2. √3 cancel, which you will be getting PE is equal to 8. Understood or what? So you got the equation for P into E as 8. Now the question is done, right? So applied for P is equal to 8 minus 8 cos 60. Cos 60 is 1 by 2 minus 4. Unit joules. Yes or no? Understood everyone? Everyone? Aha, Ullas, Rahul, Divyansh, everyone gave me the answer already. It's a great thing. Right? I hope nobody is having a doubt on this particular part. Simple question only, right? It was almost like a direct question which came in CBSE 2014. Right? So if you know the basic equation itself, you will be able to solve many questions in the board exam. Okay? So that's why you don't have to worry about anything. Keep on studying until the exam comes. Okay? Very good. Let's move forward the next question. So it is a derivation. Okay, it's a 5-mark question, I think. So deduce the expression for the electrostatic energy stored in the capacitor of capacitance C and having a full charge of Q. So we'll do the questions one by one. Understood? What is it? Deduce the expression for the electrostatic energy. So let's see where this energy is stored, or how energy is stored in a capacitor. So let's see, you are having a capacitor. Look, you are having, okay, I'll draw it. Okay, you are having a capacitor like this, and it is connected to an external cell. Okay, so once I start connecting this particular capacitor plates to an external potential of V, what will happen? The charges will get acquired, the plates will be stored with some charges. Okay, it start to build the charges, and you know that the maximum charge it can attain is given in the question as maximum is Q. So supposing that before reaching the maximum value of Q, the amount of charge present is equal to, I'm telling that this is having a charge of Q. Okay, this is having minus Q, which means the charge on it is plus Q and minus Q. Okay, what I told, the maximum charge the capacitor plates can hold is how much? Capital Q, and in between that, before reaching the maximum value of the capacitor plates, okay, charge on the capacitor plate, the intermediate value is a Q value. Fine. Okay, now we are going to see how the capacitor is storing the energy, or what is the need for the storage of energy in the capacitor plates, or how it is happening. Look, you know that if the charges again has to be developed on this particular capacitor plate, what is actually happening? Actually, if I want to build more charge, I am taking a small charge of delta Q from this negative and bringing it to the positive charge, right? So what happened? Negative charge over here increases and positive charge over here increases. Who is doing this particular thing? Who is doing? The external cell is doing. So whenever a charge is moved in a potential difference, what will happen? A work is done, and whatever is the work done, that is stored as the potential energy in the capacitor plates. Right? So that is how the capacitor plates is having the potential energy. Okay, now for this particular purpose, how much work I have to do? For changing this particular charge of delta Q from the negative plates to the positive plates, how much work I have to do? Work done is equal to change in potential energy. Right? Okay, change in potential energy is equal to Q into, here the charge is equal to delta Q into delta V, which means the potential difference between the capacitor plates. I hope you know this. Potential energy is equal to charge into potential, right? So that is equal to dQ. In the case of a capacitor of capacitance C, how will you write the equation? C is equal to Q divided by V. I hope you know this equation, everyone. And so V will be equal to Q divided by C. So I'm going to substitute it over here. This is Q by C. So now the equation becomes Q by C into dQ. What is this? This is a small work done for taking a small amount of charge delta Q. And if I want to take the entire charge, what I have to do? Who will tell me? If I want to take the entire charge from this negative to the positive capacitor plates, how much energy I have to do? How will I find out? How will I find it out? From this particular equation, whatever we have over here, how will I find out the total energy required or the total energy stored? Very good. Integration. Very good, Aditya, Nandini. Okay, Ullas. So I have to do the integration, and the integration is for which variable? The charge. Okay, the charge initially was 0. Initially on the capacitor plate was 0, and I have to integrate the charges till it becomes the maximum value of Q, which is given in the question, right? Okay, so 1 by C is a constant. It comes outside of the integral. Q into dQ is how much? Q square by 2, right? Q square by 2. Applying lower limit and the upper limit, what will be the final answer? Final answer will be equal to Q square divided by 2C. Understood? Okay, so many were giving me the answers. Now I just want you to tell me whether you guys have understood this particular derivation and also the concept behind this. The concepts is really important if you guys are preparing yourself not only for this board exam, if you're preparing yourself for the JEE and JEE Advanced also, which we also need exam. All good, Nandini? What about others? Give me a yes. Let me also feel that active thing or also the energy which you guys are also feeling now. Understood? All good. Rakvi, Aditya. Okay, very good, very good, very good. Awesome. So, shall we move forward the next question? Next question. Okay, what is said in the next question? How will the energy stored, which means this energy which is q square by 2c, and the electric field inside the capacitor affected when it is completely filled with a dielectric material of dielectric constant K? Which means now in this capacitor plates, in between the capacitor plates, I was having the air. If I fill this particular plate, which means space, okay, with a dielectric constant, which means some other material with a value of K, how will this energy changes? Okay, and what will be the change in the electric field also? So let me clear this. So first we'll talk about energy, right? Energy equation we have already seen. What was the equation? Energy is equal to, okay, energy was equal to q square divided by 2c. So when the capacitor plate is filled with a material of some material of dielectric constant K, we have to see the change in the C. So what is the formula for capacitor plates, which means capacitance of a parallel plate capacitor? Okay, I'm sorry. So that is equal to A epsilon 0 divided by D. Right, this is a formula for capacitance. When it was air in between, that's why we have the permittivity as epsilon 0. So if it is not, which means in this particular case when it becomes C dash, new capacitance is equal to A into whatever is the permittivity of the material which you are using divided by D. Right, and how will you introduce the dielectric constant K? You know that the dielectric constant K is equal to epsilon divided by epsilon 0. So this epsilon can be replaced by what? Can be replaced by C dash is equal to A into epsilon is equal to K times epsilon 0, K times epsilon 0 divided by D. Right? Okay, so how will it be? K into A epsilon 0 by D is equal to A epsilon 0 by D is equal to the initial capacitance. So understood till here? Understood till here? Now let us see what is happening in the energy. What was the equation for energy? It was q square by 2c. So now the energy E dash will be equal to q square by 2c dash, which is equal to q square divided by 2. C dash is equal to how much? K times of C. So this is equal to 1 by K into q square by 2c can be written as what? This q square by 2c, which means q square by 2c, okay, can be written as the previous energy. So E dash is equal to, the previous energy is equal to E by K. So I don't want you to get confused. Okay, let us use it as U energy, U dash, and U dash U by K for the energy, because electric field E, we are already using it for what? Electric field. Yes or no? Sonakshi, Aryan, yeah? Okay, now we have seen what is happening with the energy. So shall we also see what happens to the electric field? Yes? Okay, so let's see what happens to the electric field, because you know that capacitance C is equal to, look. Okay, capacitance C is equal to A epsilon 0 divided by D, and this capacitance is already given by Q divided by V. I hope you know this equation. C is equal to Q by V. Yes, C is equal to Q by V. Okay, now you have to know one more thing. V is equal to, how V is related to electric field. Who is going to tell me? Who is going to tell me how V and electric field is related to each other in the case of a constant electric field? Who is going to tell me the answer? Give me the answer. No one knows? No. The potential V is equal to, I hope you remember, V is equal to integral of E dot ds. You might have done in the starting of this, right? So if the value of E is a constant, this was, E was a variable. If E is a constant, you can do what? E into the distance between the plates, right? Very good, Gaurav. Who all told me the answer? Ankita. Okay, very good. So V, I am going to write it as E into D. So A epsilon 0 by D is equal to Q by AD, or you can write A epsilon 0 divided by A epsilon 0 is equal to Q by E, or electric field is equal to Q divided by A epsilon 0. Right? Now you got the formula. What do you got? We got the formula for electric field is equal to Q by A epsilon 0. Now, in the new case, what will be the formula for electric field? What will be the formula for electric field? The charge will be the same, area will be the same, but epsilon 0 will become epsilon, right? Okay, so Q divided by A into epsilon 0. Epsilon, how will you write? K times epsilon 0. So that is equal to 1 by K. That is equal to 1 by K. Q by A epsilon 0 can be replaced by the previous electric field. Now understood? The new electric field is equal to 1 by K times the previous electric field. All good? Understood, Ankita? Abhi saying, who all are there? Prashant, Ragvi? Tell me yes or no, so that we can move to the next question. Again, so many questions are waiting for us. Tell me fast. Very good. Yes. So let's move to the next question, which is waiting for us. What is it? Okay, we are having a very 5-mark question. So what does it say? Are you all ready for the 5-mark question? Guys, if you do this particular question, which came in the CBSE 2018, look, it is on CBSE 2018. So you have to think the way of the question that it comes. Read the question. Use Gauss law to derive the expression for the electric field due to a straight, uniformly charged, infinite line of charge density lambda. So you are having an infinite line charge, okay, where the charge density is lambda. What do you mean by the charge density? It is a charge per unit length. The total or the charge which is there in a unit length of that particular line is called as lambda, right? Good. So we have to find out the electric field produced by this uniform line charge at a distance of r. That is a simple as that is a question, right? So how will we do that? So we'll do in this particular slide, okay? So we are having an infinite, we are having an infinite line charge, and I want to find out the electric field which is at a perpendicular distance of r from this, okay? So positive charges are there. So which law we will use to find out the value for electric field? Guys, tell me which law we will be using. Who is out there to give me the name of the law? Fast. Big chocolate, I'll send you home. Tell me fast. Very good, Ragvi, Saima. It is Gauss law. For finding out or to apply the Gauss law, what we should be having? First, we should find out a Gaussian surface, right? A surface which is uniform in nature and which have a uniform value of the electric field. So what shape will suit best for this line charge? Which will be suiting it best? Which will be suiting it best? A cylinder, right? So I can choose a cylinder. For this cylinder, how many surfaces are there? It has 3 surfaces. One, the upper cylindric, which is circular surface, downward circular surface, and this cylindrical surface, right? So it has 3 different surfaces, right? So the total electric flux phi is equal to given by 1 by epsilon 0 times the charge enclosed. This is said in where? This is said in the Gauss law, right? Okay, so phi is equal to integral E dot ds in the first surface plus integral E dot ds in the second surface plus integral E dot ds in the third surface is equal to 1 by epsilon 0 times the charge enclosed. How will I write the charge enclosed if lambda is defined for this particular line charge? Lambda means the charge per unit length. Think that this particular line charge is having L length. So what will be the total charge Q? Lambda is equal to Q divided by L. So Q will be equal to lambda times L, right? That is equal to lambda times L. I hope nobody is having a doubt in that. All good. So if I mark 1, 2 and 3, can you tell me what will be the flux lines passing through the surface 1 and 2? Who will tell me the flux lines passing through the surfaces 1 and 2? Who is out there? Who is out there to give me the answer? Very good, 0, because for this positive charge the electric field lines will be radially outwards, right? So no electric field lines will be passing through these two surfaces. So this will also become 0. This will also become 0. So when you do the derivation, you have to write line by line, because the electric field lines are not passing through the surfaces 1 and 2. So you can take E dot ds for 1 and 2 as 0. So you only have integral E dot ds for what? For the third one. Electric field is a constant as it is equidistant from the point. So E come outside of this integral. Then what you have? Integral of ds. Integral of ds means? Integral of ds, what do you mean? The total area. 1 minute, let me complete this, Rohit, okay? I'll take your doubt. So the complete area of the surface. What is the area of the surface? Area of the cylindrical surface is equal to 2 pi r into length, right? So it is how much? 2 pi r into length is equal to 1 by epsilon 0 times lambda L. Now what do you have? Electric field E is equal to 1 by 2 pi epsilon 0 lambda divided by r. So have we proved it or not? Yes or no? Have we proved this? Yes? All good? Understood? Everyone? Say yes or no? Yes? No? Yes? Very good. Okay, so let's move forward then. Next part of the question. Draw a graph to show the variation of E with perpendicular distance r from the line of charge. So how will you draw the graph? What was the formula we got? Electric field formula is equal to, we got it as E is equal to 1 by 2 pi epsilon 0 lambda divided by r. So how E is proportional? E is proportional to 1 by r. So how will I draw the graph? E and r. How will I draw the graph of E is 1 by r? As r value increases, what will happen to the electric field? Tell me. Okay, I'm sorry. Okay, Rohit, I'll try to speak very slow now. As I wanted to cover a lot many topics, that's why I was going a bit slow. Sorry, a bit fast. So if you guys want to slow down, I'll slow down, no worries. Okay, so it will decrease. Very good. So as the r value increases, the electric field value decreases. So this will be the graph. Yes, speed is good. Okay, that's good. Thanks for the support, Satyam. Okay, yes, it will be a rectangular hyperbola. Okay, very good. Next question. Now this you guys might be finding a little bit tough. Find the work done in bringing a charge Q from perpendicular distance r1 to r2. So in this case, look, in the case of a line charge, look, you are having a line charge and you are bringing the charge from r1 to r2. So this was r1. From here, this is r2. So you are having a charge of Q. Charge Q is brought from r1 to r2, right? Yes or no? Yes. Okay. So they are asking the work done. What is the formula for the work done? Work done is equal to change in potential energy. Yes. Yes or no? Change in potential energy. Change in potential energy is equal to Q into change in potential, right? Yes, I hope nobody is having a doubt. Potential energy is equal to charge into change in potential. Okay, Yashika, I took your name. So this is equal to Q into delta V is how much? How will you find out the potential difference or potential? Formula for the potential in terms of electric field. Integral E dot dx. Yes or no? Yes? Anybody is having doubt till now can ask me. Harshit, I took my name. Now give me the answer. I hope nobody is having a doubt, right? Okay, let's move forward. So q into, and it is dx, which means it is a distance which we have to integrate. From where to where we are integrating? From R1 to R2 we have to integrate. Okay, let's apply it in the formula. So I'm going to, as a space is not there, let me write it in the next page. Okay, so I'm going to write it in the next page. So let me write it. So work done is equal to q into R1 to R2 E dot ds. What is the formula for this E which we have found out now? That is 1 by 2 pi epsilon 0 lambda by r E into dr. Or okay, so E into dr. Yes or no, Aditya? Okay, good everyone. Now what all are constants in this? Q lambda divided by 2 pi epsilon 0 integral of r1 to r2 dr by r. Yes, what is integral 1 by r? It is ln r. So it is q lambda by 2 pi epsilon 0. Sorry, there was a small mistake done in this particular thing. What was that? Is delta v's formula is equal to negative of integral E dot ds. So I forgot to add that negative. I forgot to tell that. So I'm adding a negative sign everywhere. I hope nobody is having a doubt on this, right? That was a basic. So negative is there, negative is there. This is ln r with upper limit r1, r2. Yes? Let me move forward. Look. Then what do you have? ln r2 minus ln r1. ln r2 minus ln r1, log a minus log b is equal to log a by b. So it will come as ln r2 by r1. So it is minus q lambda by 2 pi epsilon 0 ln r2 by r1. If you apply negative of ln a by b is equal to positive of ln b by a. I hope you know that also, right? So this is equal to q lambda 2 pi epsilon 0 ln r1 by r2. Everyone understood? Those who have understood, give me a smiling face. Those who have understood, give me a smiling face. Guys, very good, Saima Aditya. Yes, give me a smiley. E. Very good, Mono. Okay, Aryan, I took your name. Then I forgot to take the timetable today. No worries, tomorrow I'll be sharing. My next class will be on Tuesday. That's what I can tell you. My next class is on Tuesday at the same time, 1 o'clock. I hope every one of you guys will be there. Say yes or no? Guys will be there at 1 o'clock on Tuesday? Yes? Okay, so many kisses, so many loves. I'm so happy. Okay, I'm taking everything into my mind. Okay, I'm carrying it home. Okay, yes. Thank you so much. Yes, I'll try to give, okay, because so many classes are going on. So in between, let me try. If we get time, we'll obviously do that class. So guys, I hope you have understood this class till here. Nobody is having a doubt, I suppose. Yes? Okay. So, okay, Anik, I took your name. So what I have to tell you is, I know that you guys will be having difficulty in most of the chapters or in some chapters, or so many won't be having time to solve the questions. So what you guys is need a very good guidance. So Vedantu is there to do that particular guidance. So what you have to do, come and join the Vedantu JEE crash course, which is already 12th crash course which is happening. So you'll get the live classes and you'll get the study plans, chapter wise important questions and topics. All the helps related to the crash course will be there, which means for studying for this particular thing will be there. So come and join. It actually costs 12,000 rupees. Now you can just get it that for 3,799 if you can use a code of AM12 CC. Monu Kumar, you already joined? Okay, so Monu Kumar already joined. Why others are waiting again? Okay, don't wait, come and join just for 3,799, which is very small, right, for your awesome future where you can earn lakhs of rupees. So what you have to do, go to this particular link, apply this code, get the course for 3,799. All good. So guys, I hope you guys have understood, right? So if you guys have understood, give me a like, and if you think that this class was awesome, you benefited something from it, don't forget to share it with your friends and subscribe. Okay, give me the subscription so that you'll get the notification at the same time and you can come and join me all the classes. Okay, so thank you so much for joining the live with me. So till we meet next time, bye guys. Thank you so much, Ragvi Narotan. Okay, so bye, see you soon.